Alright, let's use critical points to sketch the graph f of x is equal to 27x minus x cubed. Okay, so we're not just going to be using the first derivative test and critical points. We can also use intercepts to kind of help us with this. So let's first find our critical points. So we know that to find our critical points, we need to let f prime of x equals 0. Okay? So in order for us to let f prime of x equal 0, let's find f prime of x first. So f prime of x in this case, I'm going to do the derivative of this function, so you get 27 minus 3x squared. If I let f prime of x equal 0, I'm not going to rewrite it, right? Then you get f prime of x is equal to 27 minus 3x squared is equal to 0. I'm going to factor out the 27 minus 3x squared by factoring out a negative 3. So you get 9 minus x squared is equal to 0. And if you use difference of squares, you get 3 plus x times 3 minus x is equal to 0. So therefore, x can be equal to negative 3 or positive 3. Okay, so we know that there's going to be a maximum minimum point here. We can also understand that the degree here, we have a degree of 3, so this should tell us that the maximum number of turns that we should have in our function is 2, right? So a turn is, remember, it's a point of extrema, right? So we should have a total of 2 extrema here. Okay, now what to kind of help us out here is we could find our intercepts. Okay, so we can find our intercepts, and in this case I'm going to find my y-intercept. So to find my y-intercept, I'm going to let x equals 0, so I'm basically solving for f of 0. That's going to give me 27 times 0 minus 0 cubed, which is 0, right? So one of your points is 0 and 0. Whenever your y-intercept appears 0 and 0, you can also understand your x-intercept would be 0 and 0, but we can always test it. We can let y equal 0, and then you get 27x minus x cubed is equal to 0. And if you factor this out, right, if I factor out an x here, you get 27 minus x squared, right, is equal to 0. And then one of your roots here is going to be x is equal to 0. The other root, 27 minus x squared, is equal to 0. If I move the x squared to the other side, it's equal to 27. So x is equal to plus minus square root of 27, which you can write as plus minus 3 square root of 3. Okay? So there seems to be 3 x-intercepts. Okay? And we can also figure out our maximum and minimum points. So we know our critical points here. We just calculated this early on. And to calculate for my my y value of those points, I do f of negative 3 is equal to 27 times negative 3 minus negative 3 cubed. So make sure you write the integers properly. So you get negative 81 plus 27, which if I calculate this out, it is going to be negative 54. So one of your points here, you're going to get negative 3 and negative 54. The other point, I'm going to do f of 3 here. You get 27 times 3 minus 3 cubed, which is 81 minus 27, which is positive 54. So we have 3 and positive 54. So it's pretty straightforward. It's pretty easy to kind of tell which ones are minimum point and which ones are maximum points. This is going to be our local minimum. This guy here is going to be our local maximum. Okay, and then we can kind of create a sketch here, right? So if I did do a sketch really quickly, I'm just going to do that out here in white. Okay, so if I did do a sketch, we have our key points. Remember guys, this is a sketch, right? I'm not going to be using the units here. Okay, our key points here, we know that there is an intercept at 0 and 0, right? So one of our x-intercepts and our y-intercept is 0 and 0. The other intercepts are positive 3 and square root 3. So let's say this is here. So this is 3, square root 3, and 0. The other point here is going to be negative 3, square root 3, and 0. Right? This is an odd degree function, right? And we also know that there should be a point, right? You can understand that 3 and square root 3 is approximately 5.196. It'd probably be wise if I just kind of move this out a little bit. Right, so let's move this guy here, and let's move this guy here. Okay, and we have a point, -3 and -54. So let's say this is -3. Where I'm just drawing this arbitrarily, so this is -3, and let's say that this is 54, right, and this is -3, and then we have +3 here, and so this is +54, and let's say that this is, let's just kind of, let's say that this here is -54. Okay, so we have -3 and -54. Let's say that's like somewhere here. 3 and +54, right? And we know that we have an odd degree function. It's negative, right? So we would expect the graph to kind of look like this. Once again, this is just a sketch, guys. Right? It should curve out. Yeah, so it should kind of do something like that, right? So as long as you guys put your key points, you don't need to worry too much about the scale, because it is, once again, a sketch. I'm just gonna kind of clean that up a little bit, but right, that's the idea. That's how you can use the first derivative test, as well as previous knowledge like intercepts, the degree, turns, right, the behavior of polynomial functions to sketch a function.